So for the next problem statement that we actually truly want to actually talk about and actually solve over here is that there's something that we can actually work around with, that we can actually talk around with, that we can actually do with. Is that you remember that the very first time that we actually enter into the field is that we have this L thing that we actually go through an array of lists of like items 0, 0, 0, 1, 1, 1, 1, and then find the variable and then plant into the left side and then find the variable and then plant into the right side, and it just doesn't necessarily have to be that way, but you can do it that way itself, and that's where we actually want to endeavor into. That's where we want to actually establish ourselves into, and that's where we want to actually, you know, walk into so far. So I don't I don't exactly remember like how the problem statement looks like, but I have like a vivid chance of like understanding of what we are actually trying want to establish. And then for the very first most cases is that the very first thing is that it's not equal to, when that thing right is not equal to, okay, I think it sets up a very good foundation for how we want to actually think about this whole problem statement itself already, which is that we have like a bajillion number of like array of like items on the list, and then we have like a key value 2, which is something that we actually want to find amongst all this trash numbers, and then you happen to have the 2 again, and that's another very key moment. So we want to count how many of like those that is not the 2, that's why not equals to. So per se is that we're gonna have like 2 pointers, that's why the 2 pointers, and one is go extremely fast and the other go very extremely slow, and maybe I don't know, we can set this as like R per se, and then we set the other one as K. Okay, so um, so what we want to actually understand is like what is the thing that is like not equals to. Okay, because we want to find the 2, right? So if it's not equals to the 2, which is maybe for this very case is established as value, right? So if that thing is not equals to value, right, then we found the thing. We found the thing. So the very guide goal is that we put if statement. So if we find until that something that is like not the 2, right, then we move on, right? We move on. But other than that, then we start to move, right? I mean, so the from the very get go is that we do understand that R is like moving at like extraordinary speed, and then K is moving very slow. So it's on the very special node, it's on the very special cases, then K will move. Alright? And we are saying that it's outside of this if statement that for that case. And then we do like a K plus equals 1. Alright? So outside of this if loop, then we do a plus equals to for K. That's when the K move. Other than that, I will keep moving. I will keep on expanding. Why not have you? So the thing is this, when it's not equals to, then we add on to our new list. So we establish ourselves with a new list called my list, and we give it a list itself. So anytime that thing is like not equals to, right, then we add it into our new list, you know. um, so my list, uh, we do a pen, right, a pen, and we append the the c value for the for loop itself, right. So I think that um okay, so we do a for c in the nums, go round and round, go through every single shit, and then we do a append if that thing is not equals to value. If not, we do a plus equals 1. We don't do the plus equals to 1 for the k. We do it over here, which is L plus equals 1. And then we return L. So the L, right, will count how many times that there's like the non-value thing. And then ml.append, right, is add in all the things that is not the true. And first and foremost, we form the list. And then second of all, right, we actually count how many times that it actually happens. And that is actually basically what we actually truly want to actually achieve from the very get-go. So to actually sum this whole problem statement already out is that we know of like from the very get-go is that one of the pointer goes extremely fast and the other value go slow. Alright, and for this very much a use case is that we fully utilize the fast and the slow. And where you can actually see the thing is that the C, right, the C is the one that is moving very fast. So C will be the actually this R thing, and then for L, right, will be this K and move incredibly. No. Okay, the thing of the one that is actually moving very slow, right, is actually L. So L and K is the same thing, and then R is for this C. So one is fast, one is slow. So this C for this case is the fast one, and then the L one is the slow one. We have like that's why the if statement. So there you have it for this problem statement itself.